In the last video, we just got an overview of how the values change and how the values are initialized beforehand. Now let's take a detailed look at how this internal loop of building the Pascal triangle works. And if I can just bring in the diagram, remember we talked about seeing this for a Pascal triangle of 3 rows so that it's easy for understanding it and tracing it. So our two-dimensional array should look like this after we have built. But how did we arrive at this is what I'm planning to take a look at that. So this will be our 0th row, and this will be my first row, and this will be my second row. This will be my 0th column, and this will be my first column, and this will be my second column. And zeros I have just represented as dot since we are not interested in that for the time being. So for this example, if we start tracing the application, initially the user would enter 3. So we have an array of 3 comma 3, which I've called it as triangle. And then our row will be 0, 0 is less than 3. So we get into the loop. And what we do is, since we know that the first and last columns of a given row is always 1, we just go ahead and achieve that in the very beginning in these two lines. The first two rows, you might not really appreciate what's happening here, but we will see it in action a little better once we come to the last row. But either ways, for the sake of tracing, we'll just continue the example. So initially this will be 0, and so 0 comma 0, which is this. We are initializing it to 1, and again we just happen to do a 0 comma 0, which is also 1. It might look a little not so obvious right now, but just hang in there. And what happens to this? We have column initialized to 1, and is 1 less than 0? Remember, we are in a nested loop. The above loop is still active. 1 is not less than 0. So we will not enter into the inner part of this loop. But we are not yet done. What happens now is we will go to this, and this becomes 1 here, 1 less than 3. So we enter here. This is 1 comma 0, 1 comma 0, which is this item here. We've put it to 1, and again this will become 1 comma 1, which is this. We also make it 1 here, and we don't touch anything else. And this happens to be 1 again, and is 1 less than 1, which is not the case. So we still don't go and do anything else. And then we again come back. So now row will be 2. 2 is less than 3. We go in. This is 2 comma 0, which is this. We set to 1. And this becomes 2 comma 2, which is this element here. So we also set it to 1. So now we can get a hint of how the first and last elements are always set to 1. It's because of these two lines here. Let's continue our example. I'll probably erase this part here. Our column is 1 now. Is 1 less than 2? Yes. So for the first time, we're actually getting into this inner loop. And what happens here? Our row is 2 and column is 1. So we are trying to initialize the value for this particular element here. And what is the formula for that? Remember, we discussed the Pascal formula. We're just using the same thing here. So that is given by 2 minus 1 will be 1, comma, column is 1. 1 comma, 1 minus 1 will be 0. So we are actually pointing to this number, which happens to be 1 plus, again, what is the row minus 1 here, which 2 minus 1 is 1. And instead of column minus 1, now we just do column. So remember what our column is 1 at this point. So 1 comma 1 gives us this element here, which also happens to be 1, we end up with assigning this 2 to this element here. And that's how we ended up with this. And now that we are done with the loop, we'll just exit here, we'll come back. Row will actually be incremented to 3, and then we'll check the condition if 3 is less than 3, which is not the case. And that's when we terminate the outside loop as well. So this is actually how our two-dimensional matrix is built. And these elements remain at 0 itself. But then how is that we are not seeing this in the output? And then how is that we are actually seeing it not as a left justified diagram, if I can call this one, and we're actually seeing it as an equilateral triangle? We will see that happening in the next part of the code. So if I scroll down to the next part of the code, this is where we are actually displaying the triangle. Now you might be thinking of ways where we could have achieved this in a single set of loop. But nevertheless, just for the sake of clarity, we will have it in 2 different blocks. And the actual magic of displaying it like an equilateral triangle and also not printing the actual cells which have the 0 all happens in this piece of code. So which we'll see it in the next part. So to conclude this video, we just saw how we are building the actual 3 by 3 array with 1, 1, 1 and 1, 2, 1 by using the Pascal triangle formula we saw previously. And in the next video, we'll see how we will actually print that.